Hello, it's Mary Beth. I'm in my kitchen science lab. Because remember, wherever you do science, that is your lab. Whenever you're trying to figure something out or answer a question about how something works or observe something and learn about it, you're being a scientist. So today our lesson is about friction. And friction is a force that's created when two things try to move against each other. I am creating friction right now with my hands. You can try that yourself. That's friction. Friction kind of makes your hands warmer too when you rub your hands together. So lots of things are moved or affected by the force of friction. Here's a couple of examples. Some of you might have a bike. If you have a bike, you sometimes put on the brakes. You're riding your bike, and you're ready to stop, and you put on your brakes, either on your hand brakes or on your foot pedal brakes, and a little pad is activated to rub up against your tire, and that's what causes your bike to stop. The friction of the pad, the brake pads on the tire, cause it to stop. That is the force of friction. Here's another example. Have you ever had socks on but no shoes and slid across a wood floor or a tile floor? You just start running and whoosh, you can slide across that floor. Can you do the same thing if you have shoes on? Well, it kind of depends on the shoes, but usually not. Because the friction of the rubber on the bottom of your shoe, here, I'll show you the shoe I have on right now. Crocs. I couldn't slide on a floor with my Crocs because the friction of this rubbery bottom wouldn't let me slide. But the socks have less of a friction force, and so you can slide right across that floor. And that's pretty fun most of the time. So those are examples of friction. I have a really simple experiment that I'm going to show you, and then you can get things around your house if you want to, and kind of do an experiment with friction also. So what I have is just this little board, and I have this at the bottom, and really this isn't needed for the experiment, but it's just kind of there to catch the things that I'm going to use. And then I have 3 blocks. One is just a wooden block. One is a wooden block with a little bit of sandpaper attached to one side and a little bit of felt attached to one side. And then this is a wooden block that's wrapped in aluminum foil. And we're going to see which of these has the most friction force. All right, let's start with the wooden block that doesn't have anything else on it. I'm going to start it without even lifting up my board. And I'm going to see how high I have to lift in order for it to move down the board. Oh, it starts moving right away. Okay, so that was our block that's just wood. Let's try the one with the felt. See what happens there. Okay, I'm going to start lifting it up. It's not moving, it's not moving. I'm going a little higher, and then it starts moving. So the felt causes a little bit more friction, and so it doesn't move quite as fast down my ramp that I created. Let's try the one that's covered in aluminum foil. Here we go. Well, that kind of started to go a little bit sooner than the felt. I couldn't quite tell if it went faster than the block. In a second, we'll have a race and see. All right, lastly, let's try the one that has a little bit of sandpaper. Sandpaper is a rough thing that we use to sand down wood and make it more smooth. So it's pretty rough if you put your fingers on there. Let's see what happens. Let's see what kind of friction force it has. Lifting up, lifting up, lifting up. Whoa, it's staying on there. That's a lot of friction. What? Oh my gosh, I had to raise it this high in order for that friction force to let go. That was cool. All right, are you ready to have a little race and see which one is fastest? All right, here's our block with nothing on it. Let's do our block with the felt. And then we'll put our block with the foil. Which one do you think has the most friction force? That means which one will take the longest to start moving down the ramp as we lift it up. Let's see what happens. Whoa! We have a winner! Well, it's not really a winner because it doesn't have the most force, it had the least. This is pretty slippery, kind of like your socks going along that floor. So that one went first, then the one without anything on it, and then the one with the felt. All right, let's do one more race and we'll use the sandpaper one. What do you think is going to happen? As a scientist, you can make predictions about what you think is going to happen in your experiment. The more you try your experiment, the better you are at predicting what's going to happen because you learn by observing. All right, here's our last friction test here. Let's see what happens. Whoa. Did you predict it right? That the sandpaper would take the longest, that it would have the most friction force? I did, because I remembered that it took a while when we did it the first time. These two were pretty close together. So the aluminum foil has a little bit less friction force than the plain wood. That was fun. I would encourage you to find some things around your house that you can play around with friction. So you could use cars, or you could use blocks like I'm using and put different things on them to test them out. Just make sure that an adult is okay with whatever you're using and with whatever you put on your blocks to test them out. You don't have to have a wood board like I have. You can use cardboard, the side of a box. You can get creative to build your ramp and to test out friction. The other thing you can do if you want to just have a ramp that stays still is put some books underneath here and to hold it up like that. So have some fun with friction, and I hope that you enjoy being a scientist and learning more about this powerful force that is pretty much in our lives all the time. Thank you. Bye-bye.